Hey, grade nines. So in today's lesson, we're going to go over graphing linear relations. So I think I mentioned this in the announcements. You're going to notice that there is a lot of overlap between Unit 5 and Units 3 and 4. So if you ever look at the lessons and you're thinking to yourself, didn't we talk about this already? You're not going crazy. We actually probably have discussed it, but just in a different context. So Unit 5, the best way to explain Unit 5 is it's almost like we're summarizing all the big ideas we talked about. And the reason we talk about analytical geometry is because we're kind of merging in algebra with geometry. In Unit 3, we're kind of more focused on just the graphing part of it, just looking at a graph and kind of picking out the main points of it. In Unit 4, we talked about algebraic methods, and now we're kind of merging both different methods together so that we can solve both algebraically and graphically. So what we know, hopefully know so far, and again, this is something that in class we will fill in together, but obviously in this case, I filled this in for the cohort that's watching this, or even if you're in class and maybe just get working ahead and just want to figure out how to actually do this. I wanted to first just quickly recap what we know so far. So what we talked about with graphing a linear relation is how to graph using a table of values, and nothing wrong with table of values, but you are going to see that it is a little bit slow, and it's not always the best method. So how would you actually graph using a table of values? Well, just a little recap here. To do a table of values, you pick out a couple points that are easy for you to fill in. So in this case, I normally work with positive and negative integers. I just, for this side of just to kind of simplify it a bit more, I decided to just work with positive integers in this case. I didn't even deal with the negative integers. I just went with numbers from 0 to 5. And again, because x is independent, that means that you decide which numbers you're going to be subbing into your equation, right? So the x value is something that we actually get to decide what we are going to sub in. So we're going to sub that into our equation, and then that is going to help us to find the y coordinate. So when we sub in 0 as an example, we get 2 over 5 times 0 minus 3 is equal to negative 3. The calculation for this one's relatively easy. Because you notice that there's going to be a fraction in the equation, it's going to make it a bit more complicated for the other y values. So for example, if I sub in 1 into this equation, so I replace the x right here with 1, I get 2 over 5 times 1, which is 2 over 5 minus 3. Of course, I can subtract using fractions, so I can do this here on the side. This is just good review of how to subtract fractions. I need a common denominator, so it's going to be 5, and it's going to become 15 over 5. And of course, 2 over 5 minus 15 over 5 gives us negative 13 over 5. And I can definitely leave that as is, but most likely when we're graphing and we actually want to plot it on the graph, we normally prefer decimals. It's just easier for us to work with, but absolutely fraction is completely fine. So we'll discuss this a little bit when it's when it's preferable to use a fraction and when it's preferable to use a decimal. Generally speaking, when we're plotting out points, we want to use decimals. However, with slope, and we'll talk a little bit about this later on, it's actually better to leave it as a fraction. So it just kind of depends on what you actually want to get from the graph. So I'm going to complete the rest of the table here. And again, you can see all the answers. All I'm doing is subbing in 2 here. So I get 2 over 5 times 2. That becomes 4 over 5. And then, of course, 4 over 5, and I'll do the math here, minus 3. You know that you can simply do 4 over 5 minus 15 over 5, and that becomes 11, negative 11 over 5, which becomes negative 2.2. And again, you can verify all these answers are correct yourself. There is also another pattern that we'll see here. So obviously you can do all the calculations, but you might also notice that the y values themselves are increasing by 2.4, are increasing, yes, by 0.4, sorry, not 2.4, by 0.4, and that should not be a coincidence to you at all, because if we look at our slope is 2 over 4, which of course as a decimal is 0.4. So it makes sense that we're actually increasing by 0.4 each time that our x coordinates are increasing by 1. So that makes sense because we know that this is going to be the slope of the line, the m value there. So it makes perfect sense that the first difference here would be 0.4 the whole way through. So we're simply adding 0.4 each time to find out what the y values are. So, I mean, this method of using a table of values to graph this is nothing wrong with that, but there are going to be some flaws because the values themselves are fractions or decimals. And regardless, putting this on a graph, you're not going to get the most accurate graph. So I actually use decimals to kind of show you what the final graph looks like, but I'm kind of showing you where I can identify all the key points. So I have 0 and 3 as my y-intercept, and I circled that one because it's a pretty important point, the y-intercept there. And then I can see here that my next point is 1 and negative 2.6, 2 and negative 2.2, 3 and negative 1.8, and so on. Now, obviously, with technology, it's quite easy to see what the graph looks like. But if I had not used technology, it would be extremely hard to figure out exactly where negative 1 and negative 2.6 lies. Because if I were to guess, and again, I may not have the best accuracy here, but I would have taken a guess and said that it was maybe in this little spot right here. So a little bit underneath the line. And it's possible that in this case, 2 and negative 2.2, I could have predicted that it would be right here, which would obviously make my line a little bit off. And by making those little small errors, and it seems like a small error, but it makes your graph less and less accurate. So there's nothing wrong with the table values, but especially when there's fractions involved in the equation, you're not always going to get the best results if you do a table values. So is there a better way to approach this? And luckily, and obviously the other big issue with table values is that it is more time consuming. But fortunately, there is a way that we can go about this. And we don't have to spend as much time worrying about the fractions and worrying about all the little messy details. So what we do is we actually focus on finding the x and y intercepts if it's standard form, and we focus on finding slope and y-intercept if it's slope y-intercept form. So let's talk about the first one, standard form. And this first one hopefully shouldn't be anything new. We actually covered this in the last lesson. So if you watched, sorry, not, I didn't do a video for that, but if you went through the lesson on standard form, we definitely went through this step by step. So if you have standard form, you know that you can easily find the x-intercept. And we find the x-intercept by letting y equal 0. And we can easily find the y-intercept by letting x equal 0. And once you find out what the x-intercept and what the y-intercept are, once you know exactly where they are placed, you simply plot the x and y-intercepts on your graph. That's pretty easy. And then your very last step here is very, very simple. Take a straight, anything straight here. So a ruler would be good. But worst case, if you don't have a ruler, take a textbook or a book, something that has a straight edge there, and just draw a straight line as best as you can. And that would give you a pretty accurate graph without worrying about a table of values. And that's actually a lot easier to work with. And again, this shouldn't be reviewed because we actually talked about this already in the last lesson. So I'm not going to go over this one as much. I feel like this one tends to be pretty straightforward. So definitely a mic drop moment. It's pretty easy to do, right? Not too hard at all. What if it's in slope and y-intercept form? So if it's in slope and y-intercept form, that means it's of the form y is equal to mx plus b. There's a few more steps. So first thing is obviously identifying what the y-intercept is. And I think that should be relatively easy. We've done this a couple times. Basically, the constant value in your equation, it's not always the last value, but the constant value that we have is going to be our y-intercept. So we're first going to plot out where the y-intercept is. Then what we do is we are going to be counting the number of units that we need to move up or down, depending on whether the slope is positive or negative. So we're either going to count up if the slope is positive, or we're going to count down if the slope is negative. Sometimes instead of saying that, I know we're kind of used to saying the slope is rise over run, but technically it could also be something called the fall if it's negative, right? So if it's negative, then we would just be going down instead. And generally speaking, and I mentioned this before, when we calculate the run, we normally want to count the units going left to right. I know sometimes it is possible to go right to left, but just to make your life easier, I would always try to find a point that is to the right. It makes the question much easier if you just kind of remember that direction we go in. So once you find another point on the line, you are going to plot that point. And again, this other point is a point that's different from the y-intercept. And then once you have the slope, once you have the y-intercept and another point on the line, you take a straight line just like before, draw a straight line and go straight through it. And one really important thing I want to mention, when you're doing lines, make sure you put an arrow at the end. That indicates that it goes on forever, right? And it needs to go on both ends. A lot of times when people draw lines, they kind of stop the line right there. So if it's between these 2 points, they just kind of do this. That's a line segment. When we're doing lines, we need to make sure that there's arrows at the end to indicate that this goes on forever. So I'm hoping this makes sense so far. Let's look at an example. So if I ask you to graph 2x plus 5y is equal to 15, first thing I'm going to do is I'm going to identify what the x-intercept is. So my x-intercept, I'm going to let, to find it, I'm going to let y equal 0. And we did this in the last lesson. When I let y equal 0, I end up getting 2x plus 5 times 0 is equal to 15. And obviously 2x plus 5 times 0, which is 0, ends up giving me 2x is equal to 15, right? Because this just disappears. And so then we end up with a pretty easy equation, 2x is equal to 15. And then my next step here is to simply divide by 2 on both sides. And then I end up finding that x is equal to 15 over 2, which I can leave like that, or I can write it as 7.5. And that's probably going to be a little bit easier when we're plotting this point. So that means that my x-intercept is 7.5 and 0. Now to find my y-intercept, I'm going to let I'm going to let x equal 0. You always let the other variable equal 0. And again, this is going back to the last lesson that we did. So I'm simply replacing the x value with 0, and I'm going to be solving for y. So obviously 2 times 0 gives me 0 plus 5y is equal to 15. But obviously I'm adding 0, which means I'm not really changing anything in the equation there. So I have 5y is equal to 15. And that means that y is equal to 3. And again, I didn't show the steps here, but I'm hoping everyone understands how I got this. I divided by 5 on both sides, and I ended up with y is equal to 3. So I'm hoping everyone's okay with solving linear equations, because we definitely are doing it a lot more now, and I'm hoping everyone's feeling comfortable about it. So I just divide by 5 on both sides, and I end up getting 3 there. So that means that my y-intercept in this last example here is going to be 0 and 3. So again, now that I know my x-intercept and I know my y-intercept, I can then plot the 2 points and then draw a straight line going through them. Now, I will eventually show you what the graph looks like, but just before I continue on, let's look at another example. So in this second example, we're going to notice that instead of it being in standard form, so let me just try to erase this here. Instead of it being in standard form, we have an equation that is in slope and y-intercept form. So because it's in slope and y-intercept form, we first know that we have to identify the y-intercept, and the y-intercept is actually quite easy to find here. We can see here that the y-intercept is 4, because it is the b value, the constant that is by itself in the equation. So that means our y-intercept is 4. And of course, if our y-intercept is 4, we also identify our slope right after, and our slope is 3 over 4, which is, and I think I made a mistake here, 3 over 2, not 3 over 4. It's 3 over 2 because it is the coefficient of the x there. So how do we plot these? So let's just look at the first graph here. So in our first graph of 2x, let me just clear that, on our first equation, which was 2x plus, let me just go back here, 2x plus 5y is equal to 15. We already identified that the x-intercept was 7.5, which is a decimal itself, but luckily 7.5 is easy to identify, and the y-intercept is 3 here. So then all we had to do is take a straight line going through it, and of course I know the line is already drawn here, but I just want to show you how I can do this myself. Just take a straight line like that, and we can see here that it crosses through both of them. So this is our equation of the line. Now, just a quick thing here, you might notice that the slope is negative because it's going down to the right, and this might throw some of you off, because if you look at the equation itself, because you might look at this the coefficient of x and notice, oh, it's positive. So doesn't that mean that the slope should be positive? But remember, when we put this in slope y-intercept form, we actually have to isolate for y, which means that we bring the 2x over to the other side. So when you bring the 2x over, it actually makes the slope become negative. So just kind of keep that in mind, that even though it looks like it might be positive because the coefficient of x is positive, when we put it in the form of y is equal to mx plus b, we actually notice that the b value itself becomes negative. So because it's negative, then that means the slope is negative. So just kind of keep that in mind. Sometimes that kind of throws people off in their answer there. So that's how we do the first graph there. Pretty easy. The second graph, this one is where people might struggle, might be a little bit new, because like I said, the last example we covered in the last lesson. So in this one, we start off with the y-intercept. And then we think to ourselves, okay, well, what is a slope? Well, our slope given to us was 3 over 2, and we know that slope is rise over run. So that means that we're going to go up 3 units, 1, 2, and 3, and we're going to go across to the right by 2 units. So it's going to be 1 and 2. So that means that this is the other point on the line. And now once I've identified the y-intercept and another point on the line, I take a straight line and I draw a line going through them, and I make sure to put arrows on the ends there, and I'm done. So that is how you draw a line going through, a line that is in the form of y is equal to mx plus b. So a small thing here, is it possible for me to find other points? Absolutely, right? I actually could continue this pattern on. I could go 3 units up and then 2 across, and to find another point that's up here. I also have a different option of going, instead of going to the right, I could go to the left. Now, when you're going to the left, I would just warn you, be really careful with this. This is where people make mistakes. So I could go to the left, but then that means that my direction kind of changes, right? So if I decide to go to the left, you almost want to think of it this way. That means that my run is actually going to be negative. But because the whole entire slope has to be positive, that means that my rise that should have been positive is actually now going to be negative. So instead of going up, I'm actually going to go down. So I'm going to go 1, 2, 3, 3 down, and 1, 2, 2 across. So that means that the other point would be -2 and 1. So even though I already had this point 2 and 7, it is possible for me to find another point -2 and 1 that's to the left. And if you want to be safe, you can absolutely find more than 2 points, right? 2 is the minimum, but we could find 3 points, 4 points, 5 points, however many you feel comfortable with, right? And once I have enough points on the line, and I really just need 2, I take a ruler and draw a straight line going through them, and I'm done. So hopefully that makes sense so far. So small little caveats or small little warnings for you here. First thing, what is the slope isn't a fraction, because you're going to see a couple of those examples. In the last example, it actually makes it really easy when it's a fraction, because if you have a fraction like 2 over 3, then I can easily identify this as the rise, and I can identify this as the run. And I think that's why I mentioned right from the beginning that it's preferable to leave it as a fraction, because then you can easily identify the rise or run. But if it's not a fraction, then you can make it easier for yourself. Simply make it a fraction. So for example, if I have a slope of 4, I can easily write 4 as a fraction by putting 4 over 1. And then it's clear that this is my rise and this is my run. And a good question some people ask, what if it's a decimal? I didn't actually mention this, but if it's a decimal, then what you would have to do is switch it into a fraction. And to switch it into a fraction, we kind of talked about this. You probably want to identify equivalent. You probably want to identify first an easy equivalency for this. So I know that 0.85 is 85 over 100. And then of course I can then change this into a fraction in lowest terms. So I can divide by 5, and this would end up giving me 17 over 20. So this is an example of how we could switch from a decimal to a fraction if you have to do that. Although this isn't very common, but it does occur every now and then. So if you do have a slope that is a decimal, it's preferable that you try to switch it into a fraction. The other little caveat, what if the slope is negative? We kind of talked about this a bit. If the slope is negative, then you need to be really careful because instead of a rise, you actually have a fall. So that means that we would still be counting down. And sorry, we would be counting down instead of counting up. However, the run itself, I still recommend that you still count to the right. That's the best way that we can think of it. And again, the reason we do this, and I'll discuss this because this has more to do with understanding negative slope or certain negative fractions in general. We know that if we have a negative fraction, either the numerator is negative or the denominator is negative, or the whole fraction is negative, but you can't say that both the numerator and the denominator are negative. And that's what I mean by that, right? So if it is negative, we need to make sure that only the rise itself is negative and not the run by going in the opposite direction. So we still go to the right. And again, I would just remember that we read graphs the way we read a book, left to right, and at least in the Western world, right? So let's look at an example with a negative fraction. What if I ask you to graph out negative 2x plus y is equal to negative 2x plus 5, and obviously without a table of values. So how would I do this? Well, first, let's start off with the easy stuff. We know that the y-intercept is 5 because it's the b value. It's the constant by itself. So my y-intercept is 0 and 5. Then I notice that my slope is negative 2. And because my slope is negative 2, I can actually write this as a fraction as negative 2 over 1, and the whole entire fraction is negative itself. Or we learned in unit 2 and unit 1 as well that we can also write this as negative 2 divided by 1. This gives me the exact same value, right? So I'm basically purposely placing the negative sign in the numerator, and um, that's more common to see, right? That we put the negative sign in the numerator there. And of course, the run, the denominator in this case, needs to stay positive. I can't have both of them being negative, right? Because the negative divided by negative actually gives me a positive. So I need to ensure that the run itself is positive there. So we always treat it as the run in this case, which is going to be positive. So that means that if we were to find another point on this line, starting at the y-intercept, instead of going up, we're actually going to go down 2 units, and then we're going to go 1 to the right. So keep in mind, it is possible for you to find another point on the left, but if you were to find another point on the left, it would actually be the opposite. You would be going in the complete opposite direction. Instead of going down, you would now go up because you're going in the opposite direction now when you go to the left. And of course, instead of going to the right, now we go to the left. So the reason this is allowed, because this might throw you off because you're thinking, well, if it's a negative slope, then why are we counting up? Well, you're counting up because remember, our rise or run was negative 2 over 1. And it doesn't matter. And again, remember that we can actually rewrite this fraction as 2 over negative 1. So if I rewrite it slightly different, then that means that I'm going 1 to the left because the negative direction means you're going to the left. And instead of going down, I'm actually going up because the numerator is now positive. So I just wrote it in a slightly different way. And this means that I'm going to go in the opposite direction. But again, I would always recommend finding points that are to the right. It's much easier to understand if you go to the right. And if you are confused yourself, if you're thinking to yourself, am I doing this correctly? Well, you'll know if you're doing it correctly when you complete your line. And if you notice that the line is going up to the right and it's positive, and the slope is positive itself, then you know you're in the right direction. Or if you finish the line and it's going down to the right and you know that the slope is negative, then of course you know you're going in the right direction, right? So you'll know right away whether you're doing it right or wrong just by looking at the direction of the line, right? Whether it goes up to the right or down to the right. So going back to this example here, so I first identify what the y-intercept is, which is 0 and 5. And because my slope is negative 2 over 1, I can write the rise as negative 2 and the run as 1. So when I do this, that means that I'm going to be going down 2 units like this and 1 unit to the right. So I'm going to place my point right there. And I can go again. I can go down 2 units and 1 to the right. And I can do it one more time, down 2 units and 1 to the right. And of course, as I mentioned already, you could go in the opposite direction, but I feel like sometimes this might throw you off a little bit. If you decide to go in the opposite direction, you would simply do the complete opposite of what we're doing right now. Oops. So instead of going down to, instead of going down to units, we're actually going to go up to units. And instead of going to the right, we're going to go to the left. So we go that up to the left 1. And again, I can do this one more time, up to, and to the left 1. So that means it's going to be up here. So, okay. And then of course I can extend that line, and then I just draw 2 arrows at the ends there, and there's my line. So I hope that kind of makes sense. How we set up our equation first of all, and then how we interpreted the slope and the y-intercept in that example. So final thing, we're going to talk about switching between standard form and slope, standard and slope and y-intercept form. And I meant to write slope and y-intercept. I missed that there. Slope y-intercept form. So how do you switch between these two forms? So it is always possible to switch between the equivalent linear equations, and we talked about this in the last lesson, so this isn't anything too new. So if I want to switch from standard form to y is equal to mx plus b form, I essentially just want to isolate for y, and we know how to isolate for y. That's the same as solving for a different variable. So what that means is we're going to move all the terms that are not related, that are not y, to the other side, and we are simply going to try to solve for y. It's like solving an equation, right? And we talked about this already. And then once you get the equation to look in the form of y is equal to mx plus b, you can easily identify the slope and y-intercept. If you want to go the other way around, this is not as common and it's a bit more confusing. So luckily we won't have to do it as much. But if you did want to go from y is equal to mx plus b form into standard form, you can do it by eliminating fractions that you have first, because you don't want to have any fractions in standard form. And then what you're going to do is you're going to move all the terms to the left-hand side. So let's do an example, switching this form right here into standard form. So what if I want to switch this into standard form? So what I'm going to do first is I'm going to move everything that is not y to the other side. So when I bring the 3x over, I have to switch signs. It becomes negative 3x. And when I move the negative 11 over, since I'm moving the whole entire term, I do the opposite of subtracting 11, I add 11. So keep in mind, I'm not dividing by 3, right? Because I'm not just getting rid of the 3 in front of the x. I'm actually bringing the whole entire term itself to the other side. So because I'm bringing the whole term itself, I do the opposite of adding a 3, because there's a positive sign in front. You don't see it, but it's positive. So I subtract the 3x. And then, of course, my last step here is to divide by 4 on all sides. And when I divide by 4 on all sides, I actually end up with y is equal to negative 3x over 4 plus 11 over 4. And I can simply leave it like that, or I can just ensure that the negative sign goes in front of the fraction in front of the x. So just notice the difference in this. I just put the negative sign in front, and I make sure that I leave the fraction as a distinct coefficient, right? I'm not kind of including it. I'm not putting the x in the numerator. I'm kind of separating it's a more direct way of doing it, right? I am just separating the coefficient from the variable there. And then I write 11 over 4 as my y-intercept. So here's my slope, of course, negative 3/4, and my y-intercept would be 11/4. So that's my y-intercept there. What if I wanted to, and of course I can leave it as is, but I think I mentioned this already, that when we look at slope, it's preferable to leave slope as a fraction, because then we know what the rise and the run is. But the y-intercept, because we're just simply plotting the y-intercept, we're actually not doing we're not counting the units up or down. With the y-intercept, we're simply just plotting the point. It's actually easier if we leave it as a decimal. So 11 over 4 becomes 3.75. So just keep in mind, in this case, the y-intercept is better off as a decimal. What if I wanted to go the other way around? What if I had a standard form, y is equal to mx plus b, and I want to switch it into standard form? So this is what we have in this case. So first thing, in standard form, you're going to notice that because we have a form where we have ax plus by plus c is equal to 0, there's no fractions here, right? So the first step is get rid of the fractions, and we're going to do that by multiplying both sides by the lowest common multiple, which is 3 in this case. This is actually very similar to the strategy that we use when we're solving equations that involve fractions. So what we're going to do is we're going to get rid of the fraction by multiplying by 3 on both sides. So when we multiply by 3 on both sides, we make sure that all the terms get multiplied by 3. So we end up getting 3y is equal to 2 over 3x times 3 plus 2 times 3. And of course, when I do this, I'm just going to show the work here. I get 3y, 2/3 x times 3 like this, and then plus 2 times 3. I'm going to notice that the 3's will actually cancel each other out. They cross cancel. And if you're not sure about cross canceling, I know some of you are not as familiar with it or you don't like it, you can always just multiply like normal, right? We take 2 times 3, which is 6, and 6 divided by 3 ends up giving us 2 in the end. So then we end up with 3y is equal to 2x plus 6. And now we are almost done. The next step to get this equation in this form is to bring all the terms to one side so that you end up with 0 on the other side, on the right-hand side. So we're going to bring the 2x over. And so the opposite of positive 2x is to subtract the 2x. And the opposite of adding a 6 is to subtract the 6. So we're actually going to do that on the left-hand side. We're going to take away 2x and we're going to take away 6. So then we end up with 3y minus 2x minus 6 is equal to, and then of course, since there's nothing on the right-hand side, it's 0. And then we end up with our standard form right there. Now keep in mind that I decided to just switch the order around a little bit. I normally like to put an alphabet in a standard notation that we put in alphabetical order with the variables. So we're going to put negative 2x first and then 3y next. And then we have negative 6. So we normally put it in that order, right? The x term goes first, then the y term, and then the constant by itself. And that's our standard form. So there's the homework there, and I hope this lesson made sense. I hope it was relatively easy to kind of follow. Like I said, a really important lesson because this is obviously we're not going to have a lot of graphing questions on the test necessarily, but you definitely need to know how to graph by hand. It's a really important skill, especially when you get into grade 10. So make sure that you practice with this. All right, good luck.